Hello friends, welcome back to Systematic Automation. Today I have come up with a new concept of industrial automation. This is going to be a practical application of industrial automation like PLC controllers, VFDs, SCADA in drilling rigs. Usually drilling rigs, they have majorly three components. The three components being the top drive, the mud pump, and the drawworks. In this video, we will learn how the setup is done on these cyber rigs. There's a term called cyber rig. I will explain this. This is the PLC controllers what we are using, Siemens S7-1200 PLC. Then G120 drives, one drive for top drive, one for mud pump, one for drawworks. Then on the drawworks, I have installed a proximity sensor which will sense the rotation of this drawwork drum. Usually there will be a drum here, and this proximity sensor will sense a metal piece installed on the shaft of the motor. So this will indicate the position of my drawworks. In this, what we have done is the PLC is connected to all these three drives, through a LAN network. It is Profinet network. From the PLC, it goes to the VFD1, which is top drive. From the VFD1, it goes to mud pump. From the mud pump, it goes to the drawers. This is a prototype setup wherein I have used only one PLC and three VFDs. In actual rigs, they will be using multiple PLCs for controlling each drive for its own control. Then there will be a master PLC, and the communication between these drives and PLC is through fiber optic communication. In this, we are using Profinet communication. In cyber rigs, they might be using fiber optic communication. The only difference is we might have to use a converter here between the Profinet and fiber optic. So that is a simple way of communication. For now, for this setup, I'm using only Profinet communication. Right. So coming to the PLC setup, what we have done is we have set up the PLC configuration to match this system. See, this is the PLC one, which is the master PLC, which will communicate to my top drive VFD, drawworks VFD, and mud pump VFD. And I'm using, instead of HMI, I'm using SCADA system here. So the same PLC will send all the signals to the SCADA. From the SCADA, it goes to each VFDs of top drive, drawworks, and mud pumps. So in the programming section, we have written a program for the control of drawworks, mud pump, top drive. And similarly, in the SCADA, we have designed 4 screens. One is for the main screen, then the drawworks control, mud pump control, top drive control, and there's one fault screen. So let's see the setup of this SCADA, how the setup is. So what I will do is I will launch the main screen through the SCADA. This is my main screen. I will launch the SCADA controls here. Well, here, this is the main page wherein it indicates the condition of the top drive, drawworks, and mud pump with top drive speed, drawworks position, and mud pump SPM. And there are different pages for top drive, drawworks, and mud pump. This is kind of a small mast setup I have made, which will indicate the position of top drive when we operate the drawworks. Let's go one by one. The top drive. In the top drive control, once I click the top drive control, this screen comes up wherein I can start and stop the top drive, run it in forward or reverse direction. Then I have a IBOP, open and close, for the top drive. Then I have a spin command also here. This is all programmed in the PLC. And this will indicate my top drive speed and in the gauge also it will show the speed of my top drive. This is my top drive set point, at what speed I should be running the top drive. There are some interlocks I have created. These are the soft interlocks, but in reality these will be physical switches installed on each unit. This is, for example, TDS lockout, then VFD reset, and then going to the drawworks. Again, drawworks, I have reverse and forward for the drawworks, start and stop. I can set the SPM for the, this is for the drawworks. I can set the speed of the drawworks, at what speed I should be moving up and moving down for the drawworks. Then again, I have a drawworks lockout and drawworks VFD reset if there is any fault. In the mud pump section, again, I have mud pump start and stop, and I have to set the SPM, at what SPM I should be running the mud pump. Then this will show you what is the running SPM on the mud pump. Again, this has a lockout and reset buttons programmed here. Let's start with TDS controls. In the setup here, I will keep it on, right, so that you can see the operation of all the motors. Now, in top drive controls, if I try to start top drive now here, right, so it won't let me start the top drive because it is asking me to check the interlock. The interlocks are the TDS lockout. If I remove the lockout, then I can start and stop the top drive. But see, there is a still alarm here. For example, if I again put the lockout, if I go to the alarm screen, it tells me TDS is locked out, drawworks is locked out, mud pump is locked out. So if I go back to the previous screen, which is my top drive screen, if I remove the lockout for the top drive, if I go to alarm screen, the top drive lockout is gone. Only there is a drawworks lockout and mud pump lockout. So if I remove those also, the red screen will disappear from here. For example, if I go to drawworks control, then remove the drawworks lockout, mud pump controls, remove the mud pump. So there is no such screen for alarm. There are no alarms. I can start all these units without any problem. Now if I go to top drive controls, now I should be able to start my top drive motor. Then if I if I give the speed here, this motor starts rotating, my top drive starts running, right? If I do the reverse, the top drive starts rotating in the reverse direction, right? There's some more interlocks here. At this stage, if I stop the top drive, keeping some speed reference at some level, and if I try to start my top drive, it doesn't allow me to start the top drive. It tells me reduce the speed. This is again, there is an interlock. All these interlocks are programmed in my PLC. So the fault now is I have to reduce the speed before starting the top drive. So if I reduce the speed, then if I start, so there are no alarms now, right? If I stop, then there's the option of spin. So in spin, I can put any values. For example, usually you put 20 RPM as a spin. Then if I click on spin and hold it, I have to click and hold it. The motor will spin either in reverse direction, or if I slide it to forward, it will rotate in forward direction, right? Then once I start, I click start, then I give the reference, for example, 80 RPM. This is 80, so this motor, top drive motor should be running at 80 RPM. Okay. Now next is my mud pump. If I go to mud pump controls, it has similar things. Like if I put 20 here, 20 SPM, and I try, it will not allow me to start my mud pumps by giving a 20 SPM to start with. So it asks me to reduce the speed. So what I have to do, I have to go back to 0. Then I can start my mud pump. I can give my what amount of SPMs it should be running it. So with that, so this motor has started. I'll reduce the SPM. I'll keep it as 5. So this motor is rotating now. You're not able to see the rotation because there is no mark on it, right? But this motor is running now. If I stop this here and again I try to start my mud pump, it will not stop the mud pump. Then I should I'm able to start it because I have kept the interlock for 10. So if I put 20 here and stop the mud pump, then I will try to start the mud pump. It should not allow me to start the mud pump. So it should be less than 20 SPM, right? So if I put 8 SPM, I should be able to start my mud pump. It will start at lower SPM. I can still start the mud pump, but this interlock, whether it should be 0 or 8 or 10, you can do the programming accordingly, right? So here I will stop it. There is one more interlock for the mud pump. Now, for example, my top drive IBOP is closed. Now it was in the open before. Now I close the IBOP. Then I go to mud pump. Then I keep this, although it is 0. Now if I try to start my mud pump, it comes with a new fault. It says IBOP closed. So it will not allow me to start my mud pump. This is the IBOP interlock system, what you see on your rigs. So what I have to do, I have to go back to top drive, then open IBOP, then go to the mud pump, then I should be able to start it. So if I start, if I say 20 SPM, the motor will run at 20 SPM, right? So, well, now I'll keep it as 0, start my mud pump, right, 0, then start my mud pump. I should be able to see my speed now because I put the marker there. So my mud pump is running, and now if any of these units, if I press the lockout, the units will stop immediately because this is a safety interlock what we have. Same way with the top drive, if I go press the lockout, the top drive stops, right? So if I remove the top drive lockout, it still shows alarm here because my mud pump is in lockout condition. So I'll go back, remove the lockout on mud pump. So this is what is my mud pump operation and top drive operation. So let's start top drive. Okay, it doesn't allow me to start the top drive because I'll have to reduce the speed now. So once I start, then I can run the top drive in forward direction. I'll go to mud draw a mud pump, keeping the SPM at 0. I'll start mud pump. I'll give 10 as a SPM for the mud pump. Now, if you see there's a mast, there is no movement on the top drive on the mast. For the movement of the mast, as I told you, I have installed one proximity sensor which will sense the rotation of this motor. Once it senses that rotation, then you should be able to see the movement of this block on the mast. So let's go to the drawworks screen. So once I go to the drawworks screen, so now I can run. Now because it is in lower position, if I start my drawworks here in the forward direction, right, it has started now. I'll give some reference. The top drive starts. See, the block moves because it is taking signal from here. If I make the 0 speed 0, it will stop and the block movement will also stop. Note that my mud pump and drawworks are still in running condition. Right? Let's see what happens once it goes to, if I increase, it goes faster. So just note what happens when it reaches to some distance. Let me stop it here. See, you will see some alarm anti-collision. So because that top drive has reached to the maximum up condition. So in that condition, my top drive, the drawworks automatically reduces the speed. All these functions you can see on the main page also. Let it go to the highest position. I have set highest position as 90 feet probably. So once it reaches to 90 position, the drawworks automatically stops at that position. It is still moving at very slow speed. This is anti-collision region. Okay, let it go further up, up. It is going up very slowly. Even if I give full command here, it will not go. Now see, at maximum height, the drawworks stop, right? It will not go up any further. Even if I increase my speed to any amount, the drawworks is in stop condition. So I'll bring it back. Now I can only bring it down. If I bring it down, it starts coming down. The top drive starts coming down. Then again we will go back one more time on the up. See again, when it reached the zero position, the drawworks stopped on its own because it is in anti-collision region. If I go to forward, I'll slide it in forward. Then I will go and check on the main screen. It shows the drawworks position, right? So the note that the moment it reaches to around 70 position, it will slows it down. See, the moment it reaches to 70 feet height, the drawworks automatically slows down because it is in anti-collision region now. Right? It will stops at a position where the maximum height is set. All these settings are done in my PLC program. Let's see what is the maximum height we can move the block up on the mast. 82. Note that the drawworks is going very slow now because it is in anti-collision region. The SPMs are fixed. The top drive speed is at 80. The only drawworks. Now at 88, it has stopped. So I cannot move it further up. The only thing we can do is go to drawworks. Then I can bring it to forward, right? Then if I go to main control, it will starts coming down. It is reducing the position. Note once it reaches to zero position, the drawworks will stop automatically. It stopped at zero position. All these settings can be programmed. See, I have made a simple graphics here. So if you know how the SCADA, the PLC programming works, then you can make similar screens, top drive screen. If I go to top drive, if I stop it, goes back to, so the top drive is showing red here. That means the top drive is stopped. The mud pump is still running. If I go to mud pump, if I stop it, go back to the main screen, it is stopped. The drawworks is still on, but it is not in rotation because the rotation speed has become zero because it is in anti-collision, right? So if I go to drawworks again and I will do forward, see the anti-collision has gone now. There is no anti-collision alarm on the main screen as well. It will appear only when the drawwork position is around 70 feet. Once it is in 70 feet, anti-collision region and the drawworks slows down. So in this condition, if I go and stop my drawworks, it will stop anytime. So if I go back to my main screen, you'll see all the units are in stop condition. Top drive stop, drawwork stop at 76 position, and SPM. Please note, in reality, in the cyber rigs, here I have used only a proximity sensor, but in reality, they use all encoders. So we should know how the encoder also is programmed. So in systematic automation, we are specialized in teaching the working professionals, especially chief electricians, senior electricians. We teach them with all this setup. We do online and offline courses. Uh, so you can always call us on our number, which you can see in the starting of this video. We have displayed all our contact numbers. You can reach us on WhatsApp. So if you are interested, we can do the online classes. And if you have good enough of people for you to do the offline classes, we do visit your premises or place wherever you ask us to come. We come there with all these simulators and do hands-on trainings. Hope you liked this video, and thank you very much for watching. Kindly share this video with your friends, and do follow us on YouTube for similar videos. In coming up videos, I will do some sessions on how exactly this complete programming is done. Uh, all the program done in PLC. I will give a small demo on how to do all this programming. So this is the PLC programming, which you can see. All this programming, how the configuration is done, how the screens are designed, all these screens, how these screens are designed, how the tags are connected, tagging is done. So I will do small sessions on basics of programming the PLCs and the SCADA in coming sessions. So do follow us and subscribe to our channel. You will get the links as and when we upload the videos. Thank you very much for watching. Do support us. Thank you.